Hey guys, I'm Jason Manarroo, a Eng undergrad student, and I've been working on SmartScan. So this project has so many applications, so let me just start with a problematic scenario. So in the nuclear sector, inspections need to be performed on nuclear reactors, and that also entails inspections on the tools used to inspect nuclear reactors and so on and so forth. And all this is done manually, by the way. So these technicians are just taking everything apart, inspecting the insides, and then we propagate up the chain until, everything's inspected. And time is money, right? So let's minimize it. So introducing CTIMS, the project I've been working on this summer. So CTIMS serves as a software system that performs AI-driven defect inspection of CT scan parts and components non-destructively. So that means we don't have to actually take anything apart until we know we absolutely have to, right? And so initially I was asked to test and fix issues on the CTIMS desktop application where we're able to upload scans like a reference and an input scan. So like a reference part and then the part after 1 year usage in the factory. And from here, the software would then be able to use AI defect inspection algorithms and other thresholding techniques to produce like a binary defect mask. So like that's great, but like I look at this, the computer looks at this, like what's actually missing here? Like screws, springs, like there's noise, like we don't know, right? So here's where my research contribution comes in. So I've developed like a web interface that allows you to upload scans, like the reference and input on the web, and then run the defect inspection algorithm right there. And from there you can interactively like label this binary defect mask, right? Label, annotate the 3D regions, and then this is a missing screw, this is a missing spring, right? With the 3D orthographic slicer that was developed for the web. And so this also directly communicates with the OTU lab servers, so it sends all that annotation data that you've done right to the server. And so what we end up with is some good labeled data on top of these binary defect masks, right? And so with great labeled data comes great AI models, and from here we're able to train a deep learning AI model with 3D segmentation and classification in mind to do all the annotating for us, right? And this is great because, as we get more data, we can, continuously train these models to be better and better. And also with more data, we can generalize better into more applications or generalize better within one application, for example, CTIMS. And so, yeah, like imagine these technicians now, they just do the scan, shows bolts 1, 2, and 3 are missing, so let's replace those quickly, awesome. Or like Ferraris, like they're manually assembled, every single one of them. And, we don't want any defective Ferraris, right? And those systems are super complicated, right? So, we put it through the scanner, oops, one of the spark plugs is defective. And that would have taken a week maybe to mechanically diagnose, right? So thank you to Dr. Hossam Gaber and Dr. Chahid Abdurazak for the great guidance on this, and I really enjoyed it. Thank you.